Hey coders. So today I was trying to figure out what to do for you guys, and I decided that I wanted to show you guys a little bit of the MicroBit. Well, instead of doing a whole new video on the MicroBit over again, I have an old video that I did last year, and I'm going to repost that video. You'll see it here in just a second. And we are going to, again, introduce the MicroBit, what it can do, and actually how it hooks into Scratch. So some of this may have changed as the year has gone on, but for the most part, the basics of the MicroBit is still the same. So please kick back, enjoy. I'm going to go through and show this to you guys, and I'll be watching it with you. So please let me know if you guys have any questions. Once again, if you're new to the channel, please subscribe, hit the like button. It'll get us out there, it'll get us known. If you would like to, we would very much appreciate it. Let your friends know. Post on Facebook, post on Instagram, do all that stuff. You can also find us on Instagram. You can find us on Facebook. You can find us on Twitter. And of course, you can just go to www.futureofcode.org and find out information about us as well. Anyway, I'll see you guys soon.
All right, so today I'm actually going to work a little bit here on, let's get rid of this. I should really save this. I make it every time, but that's okay. We are going to work using the MicroBit. And the MicroBit is a cool little microprocessor unit that was developed by BBC. That's a British Broadcasting Company. And it was developed for to teach essentially how to use hardware with software. So it is very small. Let me make sure. Oops, wrong screen. Let me make sure you guys can see. There it is, right there. So very tiny. And there's two buttons on the front here. There's an A and a B button. And then these are a bunch of LEDs. I'll show those lit up in a second. And then down below are the pins. On the back, we have a couple different things, and it's cool because it's actually labeled. So it's going to be really hard to read here, but I'll show them to you. So we have a little, this is the processor here. So the processor is also where we get our temperature from. We have USB. We have just a reset, the reset buttons right here. This is where our battery plugs in. And then what is this one? We have a compass. It's a little tiny piece right there. This is an accelerometer. And then up here, we have Bluetooth. So it actually communicates through Bluetooth to the computer. So we're going to work with this. Let me actually plug it in here, and I'll show you guys what the front of it looks like. Now this is cool. We're going to use this because we're going to start attaching some hardware to games. I'm going to show you how to do that today. So again, there is the LEDs. So I have some just random letters going across there that I had programmed into it. So not much. It's pretty cool. The processor actually runs so efficiently that it's used as the temperature because it's going to be the temperature in the environment that you're in. So if I wanted to measure the temperature, I could go put this outside, and it's going to run so efficiently that it's going to drop to that temperature outside, and it will tell us what the temperature is. It's a pretty cool little device. Okay. You guys are quiet. Everybody's being quiet. So I am going to unplug this for a second, and I'm going to show you what we're going to do here. So I'm just going to plug this into the computer, actually, so I'm not wasting the battery. And there we go. You guys can't see it, but it is plugged into the computer now. And I'm going to show you in Scratch what we do. So let's start with the first part. Again, we're going to, as you can probably see on the screen, it says Space Invaders over here. We're going to build this into Space Invaders. But first, we kind of need to see how this is going to work. We have the cat here, and last time in my backpack, I used a script code that I had built of just moving the cat back and forth, just using the A and D key. Now the A and D key, these are what we use, A is left and D is right. We're going to replace these so that we can actually move the cat by the MicroBit. So you'll notice that there is no MicroBit here right now. We have a lot of blocks, but nothing here. We have this new spot down here, though, that's add extensions. Let's get rid of our backpack. And we're going to add an extension. And we go into MicroBit. Now this requires a couple different things. We have to make sure that Scratch Link is installed and running, and that our Bluetooth is enabled. So let's see, and this was doing this to me earlier too. It is all enabled. I might have to restart Scratch Link, but it's not perfect yet. Scratch Link was disabled. Okay. There we go. So I started up Scratch Link. Now let's go in here. Looking for devices. There it is. There's that random just set of letters that was in there. And we're going to say connect. And there we go. We are connected. It gives us a green status bar there. And let's go to the editor. Now we have this new set of buttons here. Or, objects here. So, up at the top, this looks really similar. So when a button is pressed, this is very similar to, offense, when space key is pressed. We also have some logic here. We have display control. This is pretty cool. Display control is neat. We'll use this. I'm going to try to use this later. I haven't tried this yet, but going to see if we can maybe, display something. We're going to try to display text. This you can control the display, but we're going to try to display the game score. So I'm going to drop that out of there. And let's see. The first thing I want to do is I have the MicroBit here, and one of the things that it has that I showed you guys is that accelerometer. And we can actually take the key A pressed out of here and the key D pressed out of here. And what we're going to do is we're going to take the tilted. This has the accelerometer right here. And what this is front, back, left, right. We can actually tell which direction it's been tilted. So as we move this around, it can essentially judge which direction it's going. We also can look at the angle and get that a little bit, get that placed back to us here. We'll look at that in a second. We're going to set a variable to that so we can see it a little bit better. So what I want to do is, knowing left to right, I want to know, this is actually fairly easy because if we move them left, or if we tilt it left, we want them to go left. If we tilt it right, we want them to go right. And we already had this programmed in, and this was left right here. So we're going to drop that in, and right here. Now let me unplug this one more time. We might lose connection. Yep, it's going to say it was ejected. I'm going to plug it into the battery so I can show you guys. And we will try to reconnect. This is all normal. Just need to get the device back up and running. Okay. So what we want to do is when we tilt it one direction, we want it to, oops, wrong screen again. This is my left, so when I tilt it left, we want it to go left. When I tilt it right, we want it to go right. Hopefully this is doing the right thing here. So let's go ahead and run this. Okay, so let's try it. I'm going to tilt it left. Yeah, look at that. Right, left, right. The only problem is that if I only tilt it just a little bit, he moves at the same pace. It's a little awkward, but not too bad. So, all right, we have that moving, but let's see the angle. I want to actually know what angle he's moving at. So I'm going to go in here and create a variable. And you know what? Actually, my variable is already created. Let's create a variable. I don't like that. I'm going to make it for this sprite only. I don't really care if, I'm not going to be using any other sprites anyway. And I'm going to say MicroBit angle. That's what I'm going to call it. If you guys have questions, feel free to ask questions. I have the chat up here. I can see it. Okay, so I have MicroBit angle in here. I come back down to MicroBit, and what I'm going to do is I'm going to pull out the tilt angle. And then I'm going to pull out the set MicroBit angle, and I probably should have been more clear on this, because I want to know the left and the right. So let's see what this does. I haven't really played with this a whole lot, so. See, we can actually get left and right. So this is just kind of in an axis right here. So if I move this to the left, I get a positive number. If I move this to the right, I get a negative number. So the left and the right, I bet, indicates a positive and negative direction. So we're saying that positive is left right now. Let's change this actually. Let's change this to right. Sure enough, if I change it to right, right looks like it's a positive direction, and left looks like it's a negative direction. And the more I tilt it, if I keep it steady, I got, 0, 1, sometimes up to 3, or 3, -3, so plus or minus 3 degrees. But if I start to tilt it at a good angle, if I tilt it all the way diagonal like that, I get about 45 degrees. It's hard to keep it steady. So we can move back and forth here using this guy, and we can actually control this pretty well if we wanted to, or we could actually make him move quickly based on the angle. Anybody watching have an idea on how we would do that? I want to know if the farther I tilt that, how can I make him move faster? No ideas tonight? So my idea is that we would actually do probably some multiplication in here. We could actually take our angle. Yeah, use the tilt angle. Okay, yeah, use tilt angle for a speed variable. Yeah, that's kind of what I'm thinking too. And here's my thought is we know that when we go left here, it's negative, and when we go right, it's positive. And what I'm thinking, and this may or may not work, I'm just playing here. I didn't prepare for this, so I'm actually going to make them both a plus. What I want to do is tilt angle, and I want to multiply that by something. I'm not sure what. Let's see. Let's do a little math here. 10 is pretty fast for the cat here. So if we have 45 degrees, let's say that is, it doesn't seem right. There we go, that seems more accurate. So let's say a tilt angle by 0.22. Let's do that, and I'm going to do it just this direction first. And let's try this out. So, yeah, there we go. So if I move it just a little, he moves slowly. If I tilt it, let's tilt it all the way over, he moves much quicker. And we're going to do that down here too. We're actually just going to duplicate this and put it down here too. And because we said left was negative and right was positive here, we can actually control his speed based on his angle. And if we adjust this number here, like let's say if we adjusted it to 0.1, all we're doing, we're giving it a percentage. So we're essentially saying that's 22% of whatever angle. This would be 10% of any angle. 0.1 equates to 10%. So we're going to say that 10% of the angle equates to his speed. So now we have a little more control over him, but we really got to turn it to get him to move. We don't, like little adjustments don't really do a whole lot. I'm going to go back to, I'm actually going to go to 0.25. I'm going to go to 25% of the angle. And with that, even little adjustments get him moving pretty well. But we can still move fast if we tilt it back and forth at a good angle. So that was good. Yeah, use the tilt angle for a speed variable. It's very good. That's what we're doing right there, is we're determining the speed based on the angle. Oops, I just unplugged it. Yeah, I know, reconnect. Yeah, very good job. That was a great idea. It worked very, very well. All I did is, just so we didn't make him super fast, I just scaled it down a little bit by multiplying by a percentage. All right, now the other thing I want to try, and I haven't tried this yet, so bear with me, is we can connect to the pins here. So we have what's called Alligator Clips. I know the web page is using significant energy. I keep switching the wrong screen. So Alligator Clips, these little things, they can clamp on. So what we do is we have this bar at the bottom. This bar actually has all these little pins. And we can take this alligator clip and open it up like this and attach it to the pins. So it's nice and, you know, not holding on to it. Look, it's a lot of weight attached to it too. Alligator clips are nice. So we're going to try to attach this to the MicroBit. You notice as I move it around, this cat's flying everywhere. And then the other thing we have, and I don't know if this will work, but I want to try it out, is this is something that I've soldered a couple pieces of wire to this, but this little piece here is called an FSR. And an FSR is a force-sensitive resistor. So this is neat. Can anybody think, or does anybody have an idea of what a force-sensitive resistor is? Does anybody have an idea what a resistor is? Because resistors are actually very important when we're working with circuits. In fact, on the back of this little guy here, they're really, really, really tiny, but there's a bunch of resistors. Resistors can get to be really, really small, but anything that has an LED requires resistors. Has anybody that's listening right now been through the class? Because we do talk about resistors just a little bit. And force-sensitive resistors, these are special. They're really thin. Look at that, when I turn it sideways, you can barely see it. So a force-sensitive resistor, what's cool about this is resistors, when you put electricity through here, it is going to only let so much of that electricity through. It's going to slow it down. Like water in a pipe, it's like we're clogging the pipe. Now with a force-sensitive resistor, when I press down on this, it actually, the resistance changes. If I let up on it, it's going to change again. And it does depend on how much I push down on it. So this works like a weight on a scale. The harder I push, the more it's going to adjust resistance. This is a pretty cool little device. Okay, so let's try this. I'm going to try to connect this, and we're going to see if we can read some of the pins. Like I said, I have no idea if this will actually work. And I have the documentation for this up here. So I think what I'm going to do is we need to let electricity go through here, and there's a couple different pins on here, and they're probably very difficult to read, but there's ground, 3 volt, 0, 1, 2 pins, and then all those tiny ones in between are pins as well, but you kind of need a connector. There's something that this sits in that makes it easy to work with those pins. Alligator clips don't do well on those. So I believe, if I read the documentation right, that 0, 1, and 2 are analog pins. And so we're going to take the alligator clips, and let's get them untied here. They're all tied together. And the first thing we're going to do is we're going to take our red one, and we are going to attach that to the 3 volts. So I'm going to just kind of place the alligator clip here. And then we're going to take, that's not attaching very well. Hopefully that'll do. We're going to take the black one here, and we're going to attach it to 0. Now what I'm trying to do is I'm actually trying to create a trigger here using this force sensitive resistor. Same thing, we're going to connect red to red, and we're going to connect black to black. So black is going to go to our pin, red is going to go to our 3 volt, and let's see what we can do. So I want to come in here and take and let me come back and make sure nobody's saying anything. So quiet today, so quiet. Maybe everybody's out playing with what snow is left. And, okay. And I don't know if I can do this in Scratch. I think I can do this I know I can do this in Python, but I wanted to see if I can do it in Scratch. I don't know if I can. I thought I had more options here. I moved, shaken, jumped. Oh, maybe I can't do it. Well, that's okay. I was going to try to create a button to make him fire, so he could squeeze this, but I don't see. I see when pin 0 is connected, but it doesn't give me any options to do much with pin 0. We can try this, but yeah, it doesn't seem to do much. I'm trying to see if it'll write something out on the display, and it's not doing anything. Well, that's okay. Maybe next time I'll show you guys Python, and we'll actually make this a button. Because this is all new in Scratch, so I haven't been able to play with this yet. But we can actually we can use the buttons on the front. We're going to make the buttons on the front do stuff. So we can test that out and make sure it's working. I'm going to say, let's get rid of this actually. I'm going to say when button A is pressed, I want to change its color. We're going to change its color effect by 25 just to make sure it's working. And yep, there we go. Look at that. So when I move, I can move them back and forth. And then when I hit button A there, as I'm clicking that, you see his color is changing. So we know that's working. Now let's actually take this and integrate it into a game. And the game I picked was Space Invaders. So this is an old game. I'm sure all your parents are familiar with it, but I'm going to show you. Let's get through this here. What we're going to do is, see, I can use the arrow keys to move the guy at the bottom back and forth. And then I'm going to use the space bar to fire, and this is going to allow me to try to kill these guys. Oh, and I died. I wasn't paying attention. Now what I want to do is, instead of using the arrow keys, I want to use that tilt function to move them back and forth. And instead of using the space bar, I want to use the A or B key to fire. And this game, somebody did really well in this game. It's very it's very much like the original. It's very, very well done. But this requires a lot of code to do a game this intricate. So I already went through here and took a look, and I'm going to, as you notice, I remixed it. I'm going to come in here and start placing the MicroBit in. So the first thing I want to do is come down here again and click the extensions and add in MicroBit. Now this is going to do the same thing. It's going to look for it. I need to make sure it's plugged in there. Okay. Oops, let's refresh. There we go. Okay, we're going to connect our MicroBit up to it. Perfect. Go to editor. Now we're going to do the same thing that we did with the cat. We're going to add in that tilt function. So as I scroll through here, let's find it. I did organize it earlier, so it's a little bit easier to see. Here we go. We have move ship left. So this is when we know to move the ship left. And there is a move ship right here too. There we go. So he's using broadcast, he or she, excuse me, is using broadcast to move the ship around here. And as you can see, there is very similar code to what we use here. We want to know when it's tilted and when it's a certain position. We have the same thing right here, when left arrow or when right arrow is pressed. So I'm gonna get rid of this again, just like I did in our last project there. I'm gonna move those out of the way. And I forgot to add a stream marker. Let me do that right now. Let's add a stream marker. We're adding the MicroBit to Space Invaders. Okay. So once again, let's go down here and we're going to grab the tilted. We want to know when it was tilted. I want to know when it was tilted right and when it was tilted left. I'm going to just duplicate this and change it to tilted left. All right, so we want to know here and here. Now let's just try this out. Let's see if it actually took and if it's working. So I'm going to start the game here, and yeah, look at that. When I move it, it's moving back and forth. So I still got to use the space key to fire. But I'm using the MicroBit to control this. And apparently not very well, because I just got hit. Okay. So that's good, but again, I kind of like the idea of being able to move it faster or slower. So let's get rid of this code. We don't want that anymore. And let's go to this broadcast. So I want to move ship to the left. Let's go to that broadcast. So since this is a lot of code, it's hard to go through, but here it is. So move the ship to the left. There's a couple things we're doing here. We're checking the timer. We used the timer in the gravity demonstration last week, which you can still see on the channel. And then let's see, left ship move amount, left time since. Okay, let's go through here, and he's doing a set left ship move amount right here. So there is some variables going on here. That's interesting. And let's see, what is PPS? What is he calculating that? So he's trying to actually decide how much to move as well. So he's not moving the same amount each time, which is interesting. But we want our tilt to navigate that instead. And this isn't bad, but I think I'm going to actually just add some equations in here to maybe balance this out. So I think he has pretty good balance in here already. So what I'm going to do is I think I'm going to put it up here that it's a much smaller amount to move. Our percentage is lower, and I'll put a percentage higher up here. So just like we did over here, we're going to have a tilt angle by a percentage. So I'm going to try to duplicate, the thought was duplicate. I didn't mean to actually duplicate it. We're going to duplicate what we're doing here. So let's go in, and we're going to go to operators and multiply. And we're going to go back to MicroBit, and we're going to grab the tilt angle. Now, this here has a much smaller move amount than this here. We're going to play with this. We might break this. It'll be fun. So what I'm going to do is I'm going to say that I want to only move 0.1 here, but here I want to move, let's see, it was 3 and 15. I'm going to say, let's keep it at 0.25. Let's see what that does. Now I want to do this to the move ship right as well. Let's find move ship right. Like I said, I arranged this a little bit, but also let Scratch rearrange it, and it puts it in whatever order it feels like. Here we go, move ship right. So we're going to do the same thing. I'm going to copy the code up here. It doesn't. Nope. No, let's not do that. That's okay. We'll just put in new code. I think I went too far. There we go. Okay. Tilt angle, again. Multiplication. We're going to drop that inside of there and do 0.1. Drag that into the lower amount. And then I'm going to do 0.25 into the larger area there. And let's try that. Let's see what this does. So I have my MicroBit here. So yeah, actually, see how if I tilt it just a little, it moves less, kinda. We're working with his equation, or her equation, their equation. So it's a little glitchy there. We could probably edit this more to be a little more productive. But it does allow us to control back and forth a little bit smoother. We could do better. I think we could always do better. Oh, do I have tilt front? I do have tilt front. Thank you. That's why it's also not working as well. Did I do that up top too? I did do that up top too, so that's not as good. That might be why it's functioning funny. This needs to be left. This needs to be left. This needs to be right. Right. Yeah, let's try that. So, I think we could do better still. It's not bad, but it's hard to control. Moving a little bit takes twitching more than turning it side to side. You gotta kind of like twitch it to make it barely move. But that's okay. We don't have to worry about that right now. Still fun. What I want to do though is I do want to use the buttons. I want to build the button into where it'll actually shoot. So again, I can't remember where everything is here, so let's go through and we're going to find the button. And I believe it's right here when space key is pressed. So this is actually, funny enough, this is almost too simple. We can actually move the when space key is pressed. And if we go down to MicroBit, we can actually just replace this when A button is pressed. This is what is kind of nice about the MicroBit is there's not a ton to it, but you can, a lot of the functions that are already in Scratch behave really well on the MicroBit. So I'm going to do the same thing. I'm going to restart it here. And let's see. I'm going to try to press the A button here. Yeah, look at that. Works just fine. And this isn't like regular Space Invaders where you can easily fire through your own base. And it's really hard to play backwards. But now I have essentially a gamepad for Scratch. And hopefully, and I'll take a look and see if we can do it better, but we could probably build out some more buttons if we use these pins here. I'll have to take a look and see if Scratch can do it, because it definitely looks like it should be able to. I mean, it does have a when 0 is connected. It seems to want to recognize it, but I'm not sure how we can fully collect any analog through it. So that's just taking a look here, seeing if anybody has this written up already. It looks like it's actually on discussion, but nobody, let's see. Yeah, definitely discussion about it. People want to see it. Yeah, people want to see it, but it doesn't seem like anybody has a solution to that yet. That'll be interesting, because I think that we could definitely create some more buttons. You know, you could essentially create a gamepad out of this thing with, I mean, more than these two buttons here. You know, we could use buttons and hook this into a breadboard and line up 5 or 6 buttons so you can hit all of them at different times. And this is something that is available on MicroBit's site. I can show you that. Let's go to their coding editor. I'll show you guys this. I'm going to show you the one that's a lot like Scratch. There we go. Let's open this up. All right. There we go. So very similar to Scratch, as you're seeing. We have on start, which is an initialization, and then we have forever. So this is what you do to get the initial setup going for the board. But then on forever, this allows us to continue to run it. We could also see this in JavaScript if we wanted to. So this is how we would write it out if we were using the regular language. But what we would do, and it's been a while since I've used this because I've been playing more with the Scratch lately, is inputs, and we can do this. Pin 0 is pressed essentially, and we can collect information. We can collect the temperature here, the compass heading. This is all pretty cool. This is stuff that we don't quite have in Scratch yet. I'm hoping we get it soon because we do have things that notice, when it's the accelerometer is, shaken, jumped. But we need more, and I'm sure we'll see it coming. This is still, like I said, fairly new. When pin connected, if A button is pressed. Possibly, but I don't see how we could get the analog out of it yet. Yeah, I'm not really sure on that one. I'll have to look into that and see if I can do something with that. And I don't know if they just didn't focus on that for MicroBit yet, because if we go into the extensions here, they have Makey as well, which Makey is kind of another way to do input-output. If we click on Makey, it actually has, it's a kind of like a MicroBit. It looks a lot like it, but it has a bunch of keypads that you can hook up to it. So that might be why they didn't really concern themselves with adding too much to MicroBit just yet, because Makey is also there. All right, so does anybody have any questions? I might call this early tonight. Everybody's being pretty quiet, and the MicroBit was more of just an introduction. We do have these available at the Salmon Creek Club right now, and if enough people are interested, I can go buy a box of these things so that it would come out to, I think it's $15 a person. So it's not too shabby to buy them. They're not that expensive. But yeah, if I buy the box of them, it's a little bit cheaper, I think. So I wanted to give an introduction, and we'll be talking about these in the clubs. And if anybody's interested, or if enough people are interested, like I said, I can definitely buy enough of them to, to sell out to you guys, and we can get to playing with these.